Okay, so today we're going to talk about increasing and decreasing functions, and then we're going to take that and also work with the first derivative test. This beginning part is just a definition of increasing, decreasing, and it's pretty intuitive. You can read that formal definition, and you can just look to see when you evaluate, if you have x1 is less than x2, it implies that f of x1 is less than f of x2, and that's an increasing function. Where here we can see increasing as you move on the function left to right, it's going up, and that's where the first derivative is greater than 0. And then we'll also look at decreasing function. If x1 is less than x2, it implies that the function evaluated at x1 is less than the function evaluated at x2. And if we get on the function going left to right, you can see that it's going down there where the first derivative is less than 0. And then, of course, just the constant right here, where your first derivative is just 0. Like I said, that's pretty intuitive for the most part. We're going to look at tests for increasing and decreasing function. And basically, it's going to be if the first derivative is greater than 0, then we're going to say the function is increasing on that interval. And greater than 0 just means positive. Let's see, if we have, let me change these colors, the first derivative is less than 0 on the interval, then we're going to consider it decreasing. And then also we have, if the first derivative is equal to 0, then and it's constant on a to b, then we have that constant function. So we're going to look at tests for those. And then we have some guidelines for finding increasing, decreasing. Next, and it says let f be continuous. To find the open intervals, you're going to locate critical numbers. So here we are, we're going to locate the critical numbers and use those to determine test intervals. So after we do the test intervals and we evaluate them, we determine of the sign of the first derivative in each of those intervals. So we'll look at the sign, whether it's positive or negative, and then that will help us use the theorem above to determine if it's increasing or decreasing. And this isn't going to be difficult, and usually when you name intervals of increasing or decreasing, you'll use interval form of this nature. So, and you're familiar with that from pre-calculus and other courses, so that shouldn't be too bad either. So the first thing we're going to do is just practice finding intervals of increasing and decreasing. And then after that, we're going to move forward to the first derivative test. And so our first derivative test just says, let C be a critical number of a function f that's continuous on the open interval containing C. If it's differentiable, except possibly at C, then the following are the classifications. So if the first derivative changes from negative to positive, then it has a relative min, and we can name the ordered pair. If the first derivative changes from positive to negative, then it's going to have a relative max, and we can name that ordered pair. If it's positive on both sides, or if the first derivative is positive on both sides or negative on both sides, then neither a max or a min. And those are just some of the images. If you take a few minutes to look at those, you can see how they match the 1, 2, and 3 above that. So we're just going to take some time and work on a few of examples of these. Let's see. Our first example just says, find the open intervals on which this particular function is increasing or decreasing. So just the first part up here, we're going to look to see, using this, if it's increasing or decreasing. Okay, so we start with our function, which is 3x cubed minus 2x squared. And we want to take the first derivative of that. So take your first derivative. And these derivatives aren't too bad. 3 times 3 is 9x squared minus 4x. And we want to find possible critical numbers, so we set the first derivative equal to 0, as we did in the last lesson. Factor out an x right here. So you're going to have x is going to be 9x minus 4. Set each one of those equal to 0. So x equals 0 is a possible critical number, and then over here if you add 4 to both sides, divide by 9, you're going to have 4/9. So possible critical number here, possible critical number here. So what we're going to do with this part to find increase and decrease, and it says locate critical numbers. We're right here. Okay, locate critical numbers and determine test intervals. Then number 2, determine the sign when you test them to then declare increasing or decreasing. So we found possible critical numbers, and we're going to use those, and I like to set up a little table like this. I mean, I have a critical number of 0 and possible critical number of 4/9. Just put them in order according to the number line. And then the next thing we're going to do is we want to test these. So we have test intervals, and I'm going to put these up here. So I can pick anything to the left of 0. Well, I'm going to pick something easy. -1's not going to be hard to work with. I'm going to pick a number to the right of 4/9. I'm just going to let that be +1. And I'm going to pick something in between 0 and 4/9. Pick the decimal 0.1. You have options here, and you can pick different things. I chose to use values that have a 1 in them because they're usually easier to evaluate, but you could have chosen -2, -3, -4, anything to the left of 0, anything in between 0 and -4, and anything greater than 4/9. So know that you have some options there. Pick a test interval. Then you want to evaluate your function, the first derivative. So let's go test my first derivative at -1. We're going to do this first one. We're going to work here. Okay, so go to your first derivative and plug in -1. So that's, I'm going to come here. This is my first one. Right here is my first derivative. So 9x squared minus 4x, plugging in a -1. Evaluate that, and we get +13. The most important thing is you want to know, is this a positive value or a negative value? And it's a positive value, so I come here and I'm going to just make myself a note that that number was positive. Alright, I'm now going to test my next interval, so I'm going to take the first derivative and I want to test it at, moving to this next one, 0.1. So I plug in 0.1 into the first derivative function. So here it's going to be 9 times 0.1 squared minus 4 times 0.1. Evaluate that, calculate it. I got -0.31. Most importantly is the fact that it's negative. So I come up here and I make a note that that test interval calculated negative value. And we're going to do this one more time. Test the first derivative at our last one, which is +1. So go to your first derivative of 9x squared minus 4x, and everywhere there's an x, plug in +1. And here I get 5, which is +5. Let me just, and so put positive here. And the way you're going to read that is this: positive means increasing, negative means decreasing, and positive means increasing. So it went from increasing to decreasing at 0, and it went from decreasing to increasing at 4/9. But this problem says determine the intervals of increasing, decreasing. So here's how we state our answer. We're going to say increasing on the intervals from -infinity to 0. Think about it like a number line. And it's also increasing from 4/9 to infinity. So I'll say and 4/9 to infinity. It's decreasing on the interval from right here from 0 to 4/9. So the open interval from 0 to 4 nights. So our first question is, name the intervals of increasing and decreasing.